Hello everyone. In this presentation, I am going to explain about normalization in database management systems. Normalization is a process used in DBMS to organize data efficiently in tables. It helps to reduce data redundancy and improve data integrity. First, let me explain what normalization is. Normalization is a systematic process used in relational databases to organize data properly into tables and columns. The main purpose of normalization is to reduce data redundancy, which means avoiding repeated data, and to improve data integrity, which means keeping data accurate and consistent. The main goal of normalization is to break a large table into smaller, well-structured tables. By doing this, data becomes easier to manage. Duplicate data is reduced. Errors and inconsistencies are minimized. The database becomes more efficient and reliable. Why normalization is needed? Anomalies. Normalization mainly helps us solve three major problems called anomalies. These anomalies occur when data is not properly organized. First is insertion anomaly. This problem occurs when we cannot insert new data into the table because some other data is missing. Next is deletion anomaly. This problem happens when deleting one record causes the loss of other important data. The third problem is update anomaly. This occurs when the same data is stored in multiple rows, and updating it requires changes in all those rows. To solve these problems, normalization uses different levels called normal forms. Each normal form has specific rules that help organize data better, remove redundancy, avoid anomalies. Some common normal forms are first normal form, 1NF, second normal form, 2NF, and third normal form, 3NF. Now I will explain first normal form, also called 1NF. 1NF is the first step in database normalization. It focuses on making sure that the data stored in a table is simple, clear, and indivisible. The rule of 1NF states: a relation is in first normal form if all attribute values are atomic. There are no multivalued attributes. Atomic means that each field should contain only one value. The value should not be further divisible. For example, Java, C++, PHP is not atomic. Java alone is atomic. Let us look at the initial table shown in the example. In this table, the knowledge column contains multiple values. Example, Java, C++, PHP. This violates the rule of 1NF because one column is storing more than one value. This makes searching, updating, and managing data difficult. This causes problems like difficulty in searching specific knowledge, update anomalies, poor data organization. So, this table is not in first normal form. To convert the table into 1NF, we split the multivalued attribute. Each row now stores only one knowledge value. For example, instead of Java, C++, PHP, we create separate rows for Java, C++, and PHP. After normalization, each column contains only atomic values. No cell has more than one value. The table now follows the rules of 1NF. So, the new table is successfully converted into first normal form. Now I will explain second normal form, also called 2NF. 2NF is the next step after first normal form. It focuses on removing partial dependency from a table. A relation is said to be in second normal form if the table is already in first normal form. No non-prime attribute is partially dependent on any candidate key. A non-prime attribute is an attribute that does not belong to any candidate key. In simple words, key attributes identify a record. Non-prime attributes describe the record. Partial dependency occurs when a table has a composite key, more than one column as a key. A non-prime attribute depends on only part of the key, not the full key. Let us consider the given table with attributes. Student ID, student name, professor ID, professor name, grades. Here, the composite candidate key is student ID and professor ID. The functional dependencies are professor ID tends to professor name. Student ID tends to student name. Student ID tends to grades. This means professor name depends only on professor ID. Student name and grades depend only on student ID. This table violates second normal form because professor name depends only on professor ID. Student name and grades depend only on student ID. These attributes depend on only part of the composite key, not the whole key. This situation is called partial dependency. To remove partial dependency, we decompose the table into smaller tables. Table 1, Professor Table. Professor ID. Professor Name. This table stores professor details. Table 2, Student Table. Student ID. Student Name. Grades. This table stores student details. Table 3, Student-Professor Relation. Student ID. Professor ID. This table shows which student is taught by which professor. After decomposition, all partial dependencies are removed. Every non-prime attribute depends on the whole key. The database is now in second normal form. Now I will explain third normal form, also called 3NF. 3NF is the next stage after second normal form. It focuses on removing transitive dependency from a table. A relation is said to be in third normal form if the table is already in second normal form. There are no transitive dependencies. This means a non-prime attribute should not depend on another non-prime attribute. A transitive dependency occurs when a non-prime attribute depends on another non-prime attribute, instead of directly depending on the primary key. In simple words, key tends to attribute A. Attribute A tends to attribute B. So, attribute B indirectly depends on the key. Let us consider the given table with attributes. Student ID, student name, campus ID, campus location. Here, student ID is the primary key. The functional dependencies are student ID tends to student name, campus ID. Campus ID tends to campus location. This means student ID determines the student name and campus ID. Campus ID determines the campus location. Here, campus location does not depend directly on student ID. Instead, student ID campus underscore ID. Campus underscore ID campus underscore location. So, campus underscore location depends on student ID indirectly through campus ID. This is called transitive dependency, which violates third normal form. To remove transitive dependency, we split the table into two separate tables. Table 1, Student Table. Student ID. Student Name. Campus ID. This table stores student information. Table 2, campus table. Campus ID. Campus location. This table stores campus details. After decomposition, transitive dependency is removed. Each non-prime attribute depends only on the primary key. The table now satisfies third normal form. Now I will explain boys called normal form, also called BCNF. BCNF is an advanced version of third normal form. It removes some special anomalies that are not completely handled by 3NF. A relation is said to be in BCNF if the table is already in third normal form. For every non-trivial functional dependency xy, X must be a superkey. Superkey. A superkey is a set of attributes that can uniquely identify all other attributes in a table. In simple words, if we know the superkey value, we can find the complete row information. Non-trivial functional dependency. A functional dependency extends to Y is called non-trivial if Y is not a subset of X. This means X truly determines Y. Let us consider the given functional dependencies. Student tends to advisor. Advisor, course tends to student. Here, the relation includes student, advisor, course. In this example, student tends to advisor is valid because student uniquely identifies advisor. But advisor, course tends to student causes a problem. Here, advisor alone is not a superkey. Yet it is determining student along with course. So, this relation violates BCNF, even though it may satisfy 3NF. Why 3NF is not enough here? 3NF allows some dependencies where the determinant is not a superkey. But BCNF is stricter and does not allow this. That is why BCNF is needed. To convert the relation into BCNF, we decompose it into two tables. Table R1. R1, student, advisor. This table stores which advisor is assigned to each student. Here, student is a superkey. Table R2. R2, advisor, course. This table stores which advisor teaches which course. Here, advisor and course together form a superkey. After decomposition, all functional dependencies have superkeys on the left side. Data redundancy is reduced. The database now satisfies boys called normal form.